A multiple of a number can be divided by that number without leaving a remainder. For example, the first 5 multiples of 4 are 4, 8, 12, 16 and 20, so numbers that are in the 4 times table. So we need to answer true or false. 96 is a multiple of 4. Well, we can use division to work out whether 96, if you count up far enough, would be in the 4 times table. So 9 divided by 4 is 2 remainder 1, and 16 divided by 4 is exactly 4. So we don't get a remainder, so we can say that that's true. And we can see by reading a division question the other way round, we know that 24 times 4 is 96, so the 24th multiple of 4 is 96. Now, 1400 is a multiple of 100. Well, we can see straight away that that's true, because multiples of 100 always end in 2 zeros, and 1400 ends in 2 zeros, doesn't have any 10s or 1s. Now, 357 is a multiple of 7. Well, let's divide to see if 357 is in the 7 times table. There's no point dividing 3 by 7, so let's take the first 2 digits together. 35 divided by 7 is 5, and then 7 divided by 7 is 1. So this tells us that 51 times 7 is 357, which means it's true that 357 is a multiple of 7. It's the 51st multiple of 7. Now, 416 is a multiple of 9. So let's divide, and again we can take the first 2 digits together. 41 divided by 9 is 4 remainder 5, and 56 divided by 9 is 6 remainder 2. So here, because we get a remainder on the end, we know that 416 is not in the 9 times table. It's not a multiple of 9, so that one's false. Answer true or false. 56 is a common multiple of 2 and 7. So here we need to work out whether 56 can be divided by 2 without leaving a remainder and divided by 7 without leaving a remainder. So when dividing by 2, well, we can spot straight away that we're not going to have a remainder because the last digit is an even number. And 56 is in the 7 times table because 56 divided by 7 is 8. So we don't have any remainders, which means that it's true that 56 is a common multiple of 2 and 7. Now, is 108 a common multiple of 3 and 12? Well, we can divide 108 by 3. 10 divided by 3 is 3 remainder 1. 18 divided by 3 is 6. So there's no remainder on the end. And 108 divided by 12 is 9. Because 9 times 12 is 108. So we don't get any remainders from either dividing by 3 or dividing by 12. So it's true that 108 is a common multiple of those numbers. Now, is 27 a common multiple of 3 and 6? Well, 27 divided by 3 is 9, because 9 times 3 is 27. There's no remainder. But 27 divided by 6 is 4, remainder 3. 27 is not in the 6 times table. So you can say that 27 is a multiple of 3, but 27 is not a multiple of 6, so it's false that it's a common multiple of both numbers. Now, answer true or false. 56 is the lowest common multiple of 7 and 8. So lowest common multiple means that it's the lowest or smallest number that's in both times tables. If we write out our 7 times table up to 56, then write out our 8 times table, we can see that 56 is the first number that's in both times tables. There's no other numbers that are in both the 7s and the 8s that we've written here. So it's true that 56 is the lowest common multiple of 7 and 8. Now, is 12 the lowest common multiple of 4 and 6? Well, multiples of 4 4, 8, we get to 12. Multiples of 6, 6, 12. So 12 is the lowest common multiple because there are no smaller numbers that are in both the 4 and the 6 times table. So this one's true as well. So for this first question, we need to find the factors of 15. So what this question is really asking us is 15 is in what times tables? Well, it's clearly in the 1 times table and the 15 times table. 15 divided by 1 is 15. 15 divided by 15 is 1. It's also in the 3 and 5 times table because 3 times 5 is 15. Or because 15 divided by 3 is 5, so no remainder. And 15 divided by 5 is 3, no remainder. So the factors of 15 are 1, 3, 5 and 15. So what are the factors of 25? Well, finding a factor of a number, you can always include, in fact you must always include, 1 and the number itself, because these numbers are divisible, you don't get a remainder when you divide 25 by 1, or when you divide 25 by 25. 5 is also a factor of 25, because 5 times 5 is 25, or because when you divide 25 by 5, you don't get a remainder. So the factors of 25 are 1, 5 and 25. The number 25 isn't in any other times tables. For factors of 22, we can start with 1 and 22, but 2 and 11 are also factors, because 2 times 11 is 22, or because you can divide 22 by 2 and 11 without getting a remainder. So the factors of 22 are 1, 2, 11 and 22. 22 isn't in any other times tables apart from these ones. So these are the factors. Find the common factors of 4 and 8. So we can find the factors of 4. 1 and 4 are factors because 1 times 4 is 4. And 2 is a factor because 2 times 2 is 4. Now, factors of 8, we have 1 and 8, and we have 2 and 4. So the common factors of 4 and 8 are 1, 2 and 4. And we can say that 4 is the highest common factor of 4 and 8. Now notice, all of the factors of 4 are also factors of 8, and that's because 8 is double 4. Now let's find the common factors of 22 and 33. 1 and 22 are factors of 22, and 2 and 11 are also factors of 22 because 2 times 11 is 22. Now for factors of 33, we have 1 and 33 because 1 times 33 is 33, and we have 3 and 11 because 3 times 11 is 33. So the common factors are 1 and 11 because 1 and 11 are factors of both numbers, and we can say that 11 is the highest common factor of 22 and 33. Now find the common factors of 21 and 56. So 1 and 21 are factors of 21, and so are 3 and 7. Now for factors of 56, we have 1 and 56. We have 2 and 28, because 2 times 28 is 56, and we can tell that because 56 divided by 2 is 28. 4 and 14 are also factors, because 56 divided by 14 is 4. 7 and 8 are also factors. So the common factors of 21 and 56 are 1 and 7, because 1 and 7 are factors of both numbers. So the highest common factor of 21 and 56 is 7. We can use factor pairs to help us multiply. So for this first question, we have 17 times 16. Now 17 is a prime number. Its only factors are 1 and 17. But 16 is a composite number. 16 is 2 times 8. So we can multiply 17 by 2, that's the first number in our factor pair, and then we can take our answer and multiply by the 8. So 7 times 2 is 14, so 1, 4. 1 times 2 is 2, plus 1 is 3. So now we can take that 34 and multiply it by the other number in our factor pair. 4 times 8 is 32, so 3, 2. 3 times 8 is 24, plus 3 is 27. So, by multiplying 17 by 2 and then by 8, we've multiplied by 16. Our answer is 272. Now we have 23 times 21. Again, the first number in our question is a prime number, so we can't use factor pairs for 23. But 21 is 3 times 7, so we can multiply 23 by 3 and then take our answer and multiply that by 7. Now 3 times 3 is 9, 2 times 3 is 6, so we can take that 69 and multiply it by 7. 9 times 7 is 63, so 6, 3. 6 times 7 is 42, plus 6 is 48. So 23 times 21 is 483. Now 72 times 36. 36 we can make from 6 times 6. So we can multiply 72 by 6 and then take our answer and multiply it by 6 again. 2 times 6 is 12, so 1, 2. 7 times 6 is 42, plus 1 is 43. So now we can take our answer and multiply it by the last digit or the last number in our factor pair. 2 times 6 is 12, 3 times 6 is 18, plus 1 is 19, and 4 times 6 is 24, plus 1 is 25. So 72 times 36 is 2,592. Identify each of the numbers below as prime or composite. So we know that a prime number is only divisible by itself and 1, whereas a composite number has other factors as well. Now we can tell whether a number is prime or composite by dividing by the first 4 prime numbers. So dividing by 2, 3, 5 and 7. If all of those divisions give a remainder, then you know that the number is a prime number. So for 267, we can start by dividing by the first prime number, so dividing by 2, and we can see straight away that we're going to get a remainder, because all multiples of 2 end in even numbers, so end in 2, 4, 6, 8 or 0, but this ends in a 7. We can do the short division, and we get 133 remainder 1. So we get a remainder, which means we need to try dividing by the next prime number. Now there's also a rule for dividing by 3. You add up the digits in the number, so 2 plus 6 is 8, and 8 plus 7 is 15. And 15 is in the 3 times table. So here we know that we're not going to get a remainder, which means our number is not a prime number. But we can show this using short division. 26 divided by 3 is 8 remainder 2. 27 divided by 3 is exactly 9. So 267 is divisible by 3. So 3 is a factor of the number, which means that we don't have a prime number. We have a composite number. Now let's find whether 701 is prime or composite. So we can try dividing it by the first 4 prime numbers, so 2, 3, 5 and 7, and if we get a remainder to all of those divisions, we know that we will have a prime number. So 701 divided by 2, we know that it's going to leave a remainder because 1 is an odd number. But just to check, we can do the short division and we get 350 remainder 1. So we've got a remainder, so we go to the next prime number, so to 3. Now we can use the adding the digits trick, and 7 plus 0 plus 1 is 8. 8 is not in the 3 times table, so we know that we're going to get a remainder. But just to check, 7 divided by 3 is 2, remainder 1, 10 divided by 3 is 3, remainder 1, and 11 divided by 3 is 3, remainder 2, so we get a remainder. So we can try dividing by the next prime number. We know that 701 divided by 5 is going to leave a remainder, because all multiples of 5 end in 0 or 5. But to check using short division, 7 divided by 5 is 1, remainder 2, 20 divided by 5 is 4, and 1 divided by 5 is 0, remainder 1. So finally, we can divide by 7. Remember, to check if a number's prime or composite, we divide by 2, 3, 5, and 7, and if we get a remainder for all of those divisions, we know that we have a prime number. Now, 7 divided by 7 is 1, 0 divided by 7 is 0, and 1 divided by 7 is 0, remainder 1. So we've got a remainder when dividing by 2, 3, 5, and 7, so when dividing by the first 4 prime numbers. So we know that 701 is a prime number. Now, 941. We can see that it's not divisible by 2 because it ends in an odd number. So we get a remainder. To see if it's divisible by 3, we can add up the digits in the number. 9 plus 4 is 13, plus 1 is 14. 14 is not in the 3 times table, so when we do the division, we get a remainder. Now, dividing by 5, it doesn't end in 0 or 5, so again, we are going to get a remainder. Now, dividing by 7, 9 divided by 7 is 1, remainder 2. 24 divided by 7 is 3, remainder 3, and 31 divided by 7 is 4, remainder 3. So we've divided the number by the first 4 prime numbers, we've got a remainder for all of those divisions, so 941 is a prime number. A factor which is also a prime number is a prime factor. To find the prime factors of a number, we can use a factor tree. So first of all, we're finding the prime factors of 12. So we can write 12 at the top of our factor tree. Then we need to think what times what is 12. Well, 6 times 2 is 12. But then we need to think what times what is 6. Well, 3 times 2 is 6. And now, on the end of our factor trees, we've only got prime numbers. These can't be broken down any further. So, the prime factors of 12 are 3 times 2 times 2. So we can express the prime factors as a multiplication. When you multiply these prime numbers together, you're going to get 12. Now, we could have used a different factor tree. Instead of using the factors 6 and 2, we could have used 4 and 3, because 4 times 3 is 12. Then we could have broken 4 down, because 2 times 2 is 4. Now we can't break these numbers down any further, so we've got our prime factors, 2 times 2 times 3. And we can see that however we break the number down, whichever factors we use at first, we will always get the same prime factors on the end of our factor tree. Now let's find the prime factors of 30. So we can write 30 at the top of our factor tree, and now we need to think what times what is 30. Well, 15 times 2 is 30. 2 is a prime number, but we can break down 15 because it's a composite number. 5 times 3 is 15, and now at the end of our factor tree, we've got only prime numbers. So we can express the prime factors of 30 as 5 times 3 times 2. Now we could have used a different factor tree. Instead of 15 times 2, we could have broken 30 down as 10 times 3. So with the 3, we've got a prime number, so we can't break it down any further, but with 10, we can write 10 as 2 times 5. Again, we get the same prime factors on the end of our factor tree. Now, let's try finding the prime factors of 90. So 90 at the top of our factor tree, that's 10 times 9, so we can write 10 and 9. We can break 10 down into 2 times 5, and we can break 9 down into 3 times 3. But now we've got 2, 5, 3 and 3, so we've got prime numbers on the end of our factor tree, so these must be the prime factors, and we can write that as 5 times 3 times 3 times 2. Or we could have drawn a slightly different factor tree. Instead of doing 10 times 9 is 90, we could have done 45 times 2. So now we have a prime number, so we can't break this 2 down any further, but we can break 45 down. That's 5 times 9. Now 5 is a prime number, so we can't break that down any further, but we can break 9 down into 3 times 3. And now we've only got prime numbers on the end of our factor tree, so we know that these are the prime factors of 90. Now for these questions, we're adding or subtracting square numbers. So for this first question, we have 8 squared plus 5 squared. Now this squared symbol, this little 2, means multiply the number by itself. So 8 squared means 8 times 8, which is 64. And 5 squared means 5 times 5, which is 25. So if we've got 8 squared plus 5 squared, we do the squaring first, so we've really got 64 plus 25. That's 89, so that's our answer. 8 squared plus 5 squared is 89. Now we've got 10 squared minus 5 squared. 10 squared means 10 times 10, which is 100, and 5 squared means 5 times 5, which is 25. So we've done the squaring first, so we have 100, which is 10 squared, minus 25, which is 5 squared. That's 75, so that's our answer. Now 7 squared minus 6 squared. So 7 squared is 7 times 7, which is 49, and 6 squared is 6 times 6, which is 36. So we need to subtract 36, or 6 squared, from 49, or 7 squared. That's 13, so that's our answer. Now let's try squaring multiples of 10 or 100. So first we have 40 squared, and remember this little 2, this squared symbol, means multiply the number by itself. So 40 squared, we need to work out 40 times 40. That's 1,600, because 4 times 4 is 16, and then if we have 2 end zeros in the multiplication, we need 2 end zeros in the answer. So 40 squared is 1,600. So 80 squared means 80 times 80, which is 6,400. Because 8 times 8 is 64, then if we have 2 end zeros in the multiplication, we need 2 end zeros in the answer. So that's 6,400. Now we have 200 squared, and that squared symbol means we need to work out 200 times 200. That's 40,000, because 2 times 2 is 4, but then here, because we have a total of 4 end zeros in the question, we need 4 end zeros in the answer. So that's 40,000. And now 500 squared means 500 times 500. That's 250,000, because 5 times 5 is 25. Then, because we have 4 end zeros in our multiplication question, we need 4 end zeros in the answer. So 500 squared is 250,000. Now, what squared is 49? Well, 7 times 7 is 49, so 7 squared is 49. Now you could say what we've done here is found the square root of 49. We can say the square root of 49 is 7 because 7 squared is 49. Now, what squared is 900? Well, 9 is a square number because 3 times 3 is 9. So 30 times 30 must be 900 because 3 times 3 is 9, and then if you have two end zeros in a multiplication question, you need two end zeros in the answer. So, because 30 times 30 is 900, we can say that 30 squared is 900. Now, we need to find the square root of 360,000. Now, 36 is a square number. 6 times 6 is 36, which means that 600 times 600 is 360,000. Because 6 times 6 is 36, then if we have a total of 4 end zeros in our multiplication question, we need 4 end zeros in our answer. So, because 600 times 600 is 360,000, we can say that 600 squared is 360,000. Now for this next question, again we can see that 49 is a square number because 7 times 7 is 49. So 700 times 700 is 490,000 because if we have 4 end zeros in a multiplication, we need 4 end zeros in the answer. So because 700 times 700 is 490,000, we can say that 700 squared is 490,000, or that the square root of 490,000 is 700. When you multiply a number by itself and then multiply it by itself again, you get a cube number. And they're called cube numbers because they can be represented as cubes. So 1 times 1 times 1 is 1. 2 times 2 times 2 is 8 because 2 times 2 is 4, and then 4 times 2 is 8. And 3 times 3 times 3 is 27 because 3 times 3 is 9, and then 9 times 3 is 27. So 1, 8 and 27 are our first three cube numbers. And the symbol for cubed is this little 3, which means multiply the number by itself 3 times. So 1 cubed is 1, 2 cubed is 8, because 2 times 2 times 2 is 8, and 3 cubed is 27, because multiply 3 by itself 3 times, and you have 27. So 4 times 4 times 4 is 64, because 4 times 4 is 16, then 16 times 4 is 64. So we can say that 4 cubed is 64. And 5 times 5 times 5 is 125. Because 5 times 5 is 25, then 25 times 5 is 125. So we can say that 5 cubed is 125, because when you multiply 5 by itself, then multiply it by itself again, you get 5 cubed. So for this first question, we have 6 and a little 3, which we read as 6 cubed. Now this 3 means multiply the number by itself and then multiply it by itself again. So 6 cubed means 6 times 6 times 6. So 6 times 6 is 36, but then we need to take that 36 and multiply it by 6 again. Now 6 times 6 is 36, so 3 6, and 3 times 6 is 18, plus 3 is 21. So 6 cubed is 216. Now 7 cubed, so that's 7 times 7 times 7. 7 times 7 is 49, and then we take that 49 and multiply it by 7 again. 9 times 7 is 63, so 6 3, and 4 times 7 is 28, plus 6 is 34. So 7 cubed is 343. Now for 8 cubed, we can work out 8 times 8, which is 64, and then multiply 64 by another 8, because it's 8 cubed, not 8 squared. So 4 times 8 is 32, so 3, 2. 6 times 8 is 48, plus 3 is 51, so 8 cubed is 512. And now 9 cubed, we start with 9 times 9, which is 81, but we take that 81 and multiply it by 9 again. So 1 times 9 is 9, 8 times 9 is 72, so 9 cubed is 729.